Hey guys, so I'm going to go over numbers 8 through 12 in your Unit 5 packet. All right, so let's start with number 8. All right, so if we look at number 8, you kind of have a choice. You can either get the x or the y by itself in the second equation. I think either one of those would be, your best bet. So I'm going to first, why don't I get the y by itself? All right, so if I want to get the y by itself, I'm first going to take this 2x and move it to the other side of the equation. So when I do, that's going to leave me with 2y equals, now remember, when I move the 2x over here, it becomes a negative 2x. And then I'm going to bring down this positive 10. And you could have written 10 minus 2x, that's fine too. Okay, then to get the y by itself, I want to get rid of this 2. So I'm going to divide both sides of the equation by 2. Okay, so these cancel, leaving me with y equals, and then over here, negative 2 divided by positive 2 is negative 1, so negative x. And then positive 10 divided by 2 is positive 5. Okay, so let's look at what I have here. I have that y is equal to negative x plus 5. So if y is equal to negative x plus 5, can I take what y is equal to and replace it for this y in the other equation? Okay, so what I'm going to do is I'm going to take this negative x plus 5, and I'm going to put it up over here where I see the y in the other equation. Okay, so again, what I did was I brought down this x minus 3 squared and the plus sign. In place of this y, I put what y was equal to, which is negative x plus 5. Okay, so in place of this y, I put negative x plus 5. I brought down the plus 2 in the square, and then the equals 16. All right, so now I'm just going to solve this equation. Now, I know when something is squared, it means we have 2 of them, okay? But before I square this one, let's look in here. What can I do to make my job a little easier? I can combine my like terms. I can combine this positive 5 and this positive 2. Okay, so when I combine those, they're going to give me 7. And I find it's a lot easier to solve one of these equations when you first combine your like terms, because now I'm just, squaring a binomial rather than a trinomial. Okay, so again, when something is squared, right, we write it out twice. This is squared, we write it out twice. And now, let me move this up to give myself a little more room, we're going to solve. So I'm just going to double distribute. So x times x is x squared. X times negative 3 is negative 3x. Negative 3 times x is negative 3x. And negative 3 times negative 3 is positive 9. Okay, over here, negative x times negative x is positive x squared. Negative x times 7 is negative 7x. 7 times negative x is negative 7x. And 7 times 7 is 49. And we'll bring down the equals 16. Now, I know I have a lot of like terms to combine on this side of the equation, but let me set this equal to 0 at the same time, just to save myself a step. So I'm going to subtract 16 from both sides of the equation. Okay, so on the right-hand side, I have 0. All right, so let's combine. So we have, let me see, I'll underline. X squared plus x squared would be 2x squared. Okay, then if I combine negative 3x, negative 3x, negative 7x, and negative 7x, that's negative 20x. All right, and then if I combine the 9 plus the 49 and then take away 16, that'll give me what, 42? So plus 42. All right, and this is what we're solving. Now you could see right off the bat, all of these are even, right? So let's divide both sides of the equation by 2. So it's going to give me x squared minus 10x plus 21 equals 0. All right, so now let's factor this. So two numbers that multiply to 21 and add to negative 10 would be negative 7 and negative 3. I'm not going to forget to bring down my equals 0. I don't want to keep it an equation. And now that I'm solving, I wind up getting, let me split this up. I wind up getting x equals 7 and x equals 3. Now, these are not our final answers, right? These are the x coordinates of our solutions. So let me put my solutions over here. I'm going to have 7 something, right? We got to find the y that corresponds with that. and then we're going to have 3 something, right? We're going to have to find the y value that corresponds with that one. Okay, so let's go back up to our original equations. I'm going to come up here. Well, actually, I decided not to move it that far up because, look, see this equation that we created where y is by itself? Since we're solving for the y values, this might be the easiest equation to use. So I'm going to use y equals negative x plus 5. Okay, so I copied these equations from above, and all I'm going to do is I'm going to take this x value and replace it where I see that x. I'm actually going to erase this x, and let's put this 7 right there. Okay, let's do the same thing over here. I'm going to erase this x, and this time we're going to put the 3 right there. Okay, so I got that 3 from above. X equals 3. I put it where the 3 was. All right, so negative 7 plus 5 is negative 2. So we get y equals negative 2. So that is the y value that corresponds with our x value is 7. So when x is 7, y is negative 2. And then over here, negative 3 plus 5 is positive 2. So, I switched colors. I didn't mean to do that. So that's the y value that corresponds with an x value of 3. So we have the coordinate 3, 2. Right, and these, right? Okay, now if we take a look at number 9, some of you may have gotten the y by itself in the second equation, but the x is already by itself. So I'm not even going to get this y by itself. Since x equals y plus 4, can't I just take this y plus 4 and put it in place of this x in the first equation? Okay, so again, I just took this y plus 4, since x is equal to it, and replaced it for x in the first equation. So in place of this x, I put y plus 4, and then I brought everything else down. Okay, now, if I look in this first parenthesis, right, I have a 4 plus 1. We know that 4 plus 1 is 5, so I'm going to rewrite this as y plus 5 squared. And then I'll just bring everything else down. So I find it so much easier if you first combine your like terms, right, like I did right here, before I write this out twice. Because if you have to double distribute, or triple distribute, I should say, 3 terms, it's going to be a lot more work than just doing it with a binomial with 2 terms. Okay, so because both of these were squared, I wrote them out twice, and now I'm just going to double distribute. So y times y is y squared. Y times 5 is 5y. 5 times y is 5y. And 5 times 5 is 25. Okay, and then over here, y times y is y squared. Y times negative 1 is negative y. Negative 1 times y is negative y. And negative 1 times negative 1 is positive 1. Then I'll bring down the equals 18. All right, so I know I need to get this side of the equation set equal to 0, and then I'm going to combine all my like terms. So let's subtract the 18 from both sides of the equation. So that's going to give me 0. All right, so then when I combine my like terms, let's see, I have y squared plus y squared, which is 2y squared. Okay, and then we have 5y plus 5y minus y, which would be a positive 8y. Oop, let me stick with the same color. And then when we combine 25 plus 1 minus 18, 26 minus 18 would be 8. So we have plus 8. Okay, and just like the last problem, right, these are all even, so I might as well just divide by 2. And that'll leave me with y squared plus 4y plus 4 equals 0. All right, so this is a pretty simple one to factor, right? We're coming up with 2 numbers that multiply to 4 and add to 4. So that would be 2 and 2. All right, so let me give myself a little room here. If I make a t-chart, I wind up with both solutions being y equals negative 2. Now let's think about this. If this is going to be the same solution over here, right, it's going to give me the same point of intersection. I don't even have to show the work for that. So I'm going to not even bother with that side because I'm going to wind up with the same solution. Okay, now we know the y coordinate is -2, but we need to figure out what x value corresponds. So if I go back up to my equations above, actually, I'm going to use this one right here, x equals y plus 4. Okay, so x equals y plus 4. So let me just move this back up. Let me write that down. X equals y plus 4. I just changed the order of it. All right, well, what I'm going to do is, since y is equal to -2, I'm going to put this -2 where that y is. So let me erase this y, and we'll throw a -2 in there. And since -2 plus 4 is 2, we get x equals 2. Now be careful when you go to write your solution. I know I have the y written first and the x written second, but when you write a coordinate always goes x, comma, y. So the x value is 2, and then our y value is -2. Okay, so for this one, we only have one point of intersection. There's only one solution. All right, so let's take a look at number 10. Now, with number 10, I think it's definitely easier to get the x by itself in this equation than the y, because the y has a 3 in front of it. So we'd wind up with, like a fraction. Not that we can't work with a fraction, but I know you guys probably prefer not to if you don't have to. So I'm going to just subtract the 3y from both sides of the equation, leaving me with x equals -3y plus 9. Okay, so again, I got this x by itself by moving 3y over, making it negative, and bringing down the plus 9. So now I'm going to take the -3y plus 9, and I'm going to put that in place of this x in the first equation. Okay, so just to reemphasize that, I took the -3y plus 9 and put it where this x was. So I have -3y plus 9, and then I took the rest of this equation, and I brought it down. So just like the others, I'm going to first combine my like terms, right? It's going to make my life easier if I combine these before I decide to write out my parenthesis twice. All right, so that's going to leave me with -3y plus 4, right? 9 minus 5 is 4, squared, plus y squared equals 16. And now, since I have a square, I could write out this binomial twice and double distribute. All right, so -3y times -3y is positive 9y squared. -3y times 4 is -12y. 4 times -3y is -12y, and 4 times 4 is 16. And I'll bring down the rest of the equation. And same thing we've been doing with the last couple, right? Let's subtract the 16, and then we'll combine all of our like terms. All right, so on the right side of the equation, I'm left with 0. And if you notice here, I line this up under the 16. 16 minus 16 is just going to cancel. So then when we combine our like terms, 9y squared plus 1y squared is 10y squared. And then -12y, and -12y is -24y. All right, so it looks like here what we're going to do in order to factor this is we're going to factor out the greatest common factor. So if we look at these two terms, right, our greatest common factor would be 2y, which is going to leave me with a 5y minus 12 in parentheses. All right, so all I did was I took a 2y out of this term, which left me with 5y, and I took a 2y out of this term, which left me with 12. So now, if I make my t-chart and solve, I'm going to be left with, on the left side, y equals 0. If you want to show the work, you can. Okay, 2y, set that equal to 0. And to solve for y, we divide by 2, leaving us with y equals 0. And on this side, I know most of you can look at this point and say y equals positive 12 over 5. But if you prefer to show the work, you can. You could set this equal to 0. Okay, and if we add this 12 to the other side of the equation, if we add 12 to both sides of the equation, I should say, it leaves us with 5y equals positive 12. Right, you could think about it, we just took it and moved it, made it positive, and then when we divide by 5, that'll leave us with y equals 12/5. Okay, now, sorry, my pen's not doing the best job. That says 12/5. If you want to write that as a decimal, as 2.4, you can do that as well. Now, these are the y values, so when we go to write our coordinate, right, that 0, and that 12/5 comes second. Those are our y coordinates. Now we need to figure out what x values correspond with them. So let's go back up to our equation. I'm going to use this one right here. X equals negative 3y plus 9. So x equals negative 3y plus 9. X equals negative 3y plus 9. Let me write that on both sides here. And what we're going to do is we are going to replace our y, in this case with a 0. Okay, so let me replace that, erase that, and I'm going to throw a 0 in there. And over here, I'm going to replace that y with 12/5. So I'm going to erase that, and we'll throw 12/5 in there. All right, well, if we figure out what this is equal to, right, basically 0 plus 9, this is equal to 9, so x equals 9. So when y equals 0, x equals 9. So I could put that in the x spot in that coordinate. All right, and then over here, right, we're going to figure out what negative 3 times 12/5 plus 9 is equal to, and you wind up getting positive 9/5. So that is the x value that corresponds with the y value of 12/5. So that is going to be 9/5. And again, if you prefer to write these as, I mean, these are our answers, but if you prefer to write this second coordinate in decimal form, that would be, let's see, that would be 1.8, and we already said our y coordinate would be 2.4. So you could do that as well. Okay, and the last one we're going to take a look at in this video is number 11 on the next page. So you first want to get either x or y by itself in one of these two equations. Since there's a number in front of the x, I'm going to get the y by itself. It's actually super simple to do. If you think about this equation, right, here's my equal sign. If I take this negative y and move it to the right side of the equation, it's not going to become a positive y. And because I want to get this y by itself, I'm going to take this 4 and move that over to the left side of the equation, making it a negative 4. So I'll have 2x minus 4. Okay, so now since y is equal to 2x minus 4, let's take that 2x minus 4 and put it where this y is, right there. Okay, so again, all I did was I replaced this y with 2x minus 4. So I have x plus 3 squared plus 2x minus 4 squared, and then I brought down the equals 8. All right, so we're going to solve this equation, and we're going to do it the same way we've been solving all the rest, right? We know if we have a square on the outside of the binomial, we write it twice. So I'm going to write each of these twice. And then we're going to double distribute everything out. Okay, so when we double distribute, that's going to leave us with x squared plus 3x plus 3x plus 9 plus 4x squared minus 8x and then minus 8x plus 16. We'll bring down the equals 8. All right, so I'm going to subtract this 8 from both sides of the equation to get the equation set equal to 0. And when I combine all my like terms over here, I'm going to be left with 5x squared minus 10x, and then plus 17 equals 0. Okay, now here's the deal. If you try to factor this, right, it's not going to factor. You could try, but it's not going to. So here's the deal. Because we have a quadratic, right, x squared, we could either use quadratic formula or completing the square. All right, I'm going to use the quadratic formula, and let me do that up here. So I'm going to write, just because I'm kind of running out of room on the bottom, I'm going to write x equals, so negative b, negative 10 would be positive 10, plus and minus the square root of b squared minus 4 times a, which is 5, times c, which is 17, all over 2 times a, so 2 times 5. Okay, so that's going to give us x equals 10 plus and minus the square root. Now we need to figure out what all this is equal to. And it's actually equal to negative 240. So we're going to have negative 240 under the radical, and that whole thing's going to be over 10. Now we could actually stop here. Think about this. If you have a negative under the radical, doesn't that mean we have imaginary answers, right? We're going to have 10 plus and minus some imaginary answer over 10. So both of our answers, right, the one that has a plus as well as the one that has a minus, are going to include the imaginary unit. So you don't even have to finish this. They just want to know, how can we describe the two solutions? They are both going to be imaginary. So choice 1.